We're going to go for about the next, I hope, 50 minutes. I hope I don't run long. If I do, I'll step. My name's Chris Skinner. I'm a Senior Program Manager for Worldwide Education. My background really in this topic, I was an instructor I still teach, for a long, long time for VMware, teaching all of our data center product classes. Prior to that, I spent a lot of time working as an independent, doing a lot of Microsoft stuff for years and years. So the goal here is to go through some of the leading practices or best practices that we have around virtualizing Active Directory. So for the next 50 minutes or so, I hope I don't go too much longer than that, we're going to talk about ways to accomplish this and things to watch out for as we go through that particular process. You'd be surprised how many times that question comes up in a class environment, as witnessed by the fact that there's always a pretty good turnout for this type of topic, and I get a lot of questions about it too. Also, at the very end, you guys know you're all getting the slide decks, so anything that I have in a deck that shows a setting or a configuration or something like that, you can always refer back to it after the show because it'll be in the slide, and don't make yourself crazy trying to write it down. The disclaimer, if you've been to any other presentation, you certainly have seen this before. Again, you'll have access to these slides. I also at this deck put a bunch of additional links from various locations, not only ours, Microsoft's, things along those lines that reference some of the things that we're going to be talking about and some of the settings that we're going to be covering here this week too. So let's talk a little bit about objectives and goals. I guess the first thing is the scary thing. You can do it. You can virtualize Active Directory. And we're going to go through that. As a matter of fact, I'll share a slide with you of VMware's infrastructure so you can proofs in the pudding. We'll show you a little bit about what we're doing and how we're, what our situation looks like. But it can be done successfully. We have many big companies, many small companies out there doing it. It's not difficult. There's no magic to it. There's no real tricks to it. There's smart planning around it. But at the end of the day, it can be done. You don't need a PhD to make this thing happen. It can be done very well, and we have been doing it for a while. So as I said, many companies have already done this and implemented this, and away we go. So the agenda is going to look something like this. First of all, we're going to start off with the topic of why would you even consider doing this in the first place? One of the things, the old saying, if it ain't broke, don't fix it. At the end of the day, though, there are some reasons why it might make sense to actually do some virtualization of AD or completely if you want. What are the challenges, kind of road bumps, can you expect to run into as you go through this process? Definitely some things to consider as you go through an AD virtualization. There's definitely some configurations that you should probably consider strongly as well. We're going to go through those, obviously, as we get through this. Last but not least, how do I get from here to there? What's the process? I've got these physical DCs right now that are running in my environment. What's the plan look like to get me to an end result here as well? So obviously, right out of the starting grid here, we're going to talk a little bit about why would I virtualize in the first place. Well, one of the first things that probably should alleviate your concerns right now is it's supported by Microsoft. This is often, I still to this day, after the announcement that they put out a while back, periodically have clients and students say to me, well, Microsoft told us it wasn't supported. In fact, it is. And as a matter of fact, they have published and documented on their site. I think the link's at the end of the slide deck here as well. But obviously, performance, one of the other things that we can do is certainly leverage some performance issues. We'll talk about that a little bit. We'll talk about virtual machine considerations with planning on these things as well. Domain controllers are not really super CPU intensive. They're more memory intensive than they are anything else. However, there are some good planning techniques that you need to consider, and performance certainly can help you in this environment here. vSphere has added a lot of throughput. You can build these monster virtual machines now with 8 CPUs and 255 gigs of memory. And so, as we progress with each revision, there's additional enhancements that allow us to do some, really get much better performance in here. I guess this is another one to strongly consider, reducing the infrastructure costs. Remember that the whole mantra around VMware is about server sprawl, right? Consolidating or eliminating and deprecating those physical boxes that you have out there. So certainly that becomes a cost element in reducing your infrastructure as well. You also have some standardization around this. Instead of having different physical boxes from different vendors with different configurations, we build virtual machines and we can be very uniformed about how they go, and we can have full expectations when we do proper testing of what the impact of applying a patch or a fix or something along those lines on a particular virtual machine, because it doesn't matter which VM I test it on. If it works for that virtual machine, it's going to work on the others because we present the same stuff to every virtual machine. Okay, so that's another thing about that cost savings in there as well. Management obviously now have the ability to do some really test dev, proof of concept type things. We also have the ability to present a server in just minutes instead of weeks. We've talked about that. We'll talk about that a little bit here as well. And it can scale pretty dynamically as you get into that. All right, let's talk about this. I'm not going to read this to you. You guys can refer back to this again. This is from the Microsoft site. We were the first non-Microsoft virtualization platform accepted into their program. And you can see, of course, there is support for numerous applications that are defined in here. AD is one of them. So in fact, they do support Active Directory as a virtualized platform in there. Some of the cost and hardware considerations as you go through this, again, standardization avoids things like activation issues and so forth. You can repurpose multiple single-use servers now. That's one of the things as you deprecate these things across the board. Combine multiple physical server roles into separate VMs. I think many of you in this room, certainly the smaller companies, we bump up against this. Money is an object. Well, of course, at any company, I don't care who you are, money's an object at the end of the day. But smaller companies don't have the luxury of going out and buying a separate Exchange box and a separate domain controller and a separate SQL server. So sometimes they have to go through the process of consolidating these applications on the same physical machine. And, although technically you can do that in many cases, Microsoft's best practice says put them on their own box. One box, one app, one OS. That's their mantra for a lot of applications. This gives us an opportunity now to segregate applications that may be sitting multiple apps on top of a single box in here. Obviously, the more DCs that you have in your environment, the greater the logon experience can be for users as well. So, you're taking these physical boxes, you're converting them over into virtual machines, and voila, you deprecate the physical box and away we go. So from a security perspective, if any of you in this room here go back to the days of vCenter 1.0, vCenter 2.0, does anybody go that far back? You got to know that by now that vSphere's got significantly greater control over security and managing users' access to some of these virtual machines out there. So we have much greater level of permissions and control and access in our environment as well. The ASLR is available to us now to try to avoid attacks by randomizing where executables lie in memory. Isolated VM environments. Again, remember the beauty of a virtual machine. If something corrupts it or it goes awry, it has zero effect on any other virtual machine, right? Because they're completely isolated from each other. And you can have, a lot of clients have told me that when you do this, you have better control in your change management too, because obviously one of the things that becomes a challenge is the processing of just buying physical hardware and getting it all in place and so forth can be complex. A virtual machine is, in 25 words or less, a virtual machine is a software representation of a physical entity, right? And it makes it much simpler to kind of get it through that process. Test and dev environments, perhaps you're doing proof of concept. You may have developers, just a nice little animated graph here that I'll click through, that you may have people out there with developers developing an application. They need to test schema changes. So they want to take a copy of your production VM and drop it to some test server and run a bunch of battery of tests on it and see what happens, that kind of thing, and then perhaps put it into back into production if it's successful. Maybe you're doing domain reconfigurations, or you're experimenting with child domains and things along those lines. And so this gives us an opportunity, of course, to run this through. And the beautiful thing about this is I don't need a lot of physical boxes to do this. So through the use of snapshotting and cloning and things like that, you can leverage a lot of test and dev environments very quickly in their environment. Okay, so what are the road bumps that I might bump up against as I'm actually trying to go through this process? Because it's not going to be without some challenges and careful planning that you want to go through. In a broad stroke, these are the major areas that you need to consider when you start looking at virtualizing Active Directory. So we're going to go through some of these topics here and, of course, talk in depth about each of these, starting with probably the big one. Time synchronization is something to be very carefully considered as you do this, whether we're talking about 03 domains or 08 domains. Domain controllers are extremely time sensitive. This graphic here is just to put a framework around the time synchronization issue with regards to Active Directory. Okay, remember this is showing simply a parent-child relationship. And who's the master timekeeper in every domain? PDC Emulator, right? Now remember that role is one of the five FSMA roles that we've got out there, but it's very important. Each domain has one of these, and he becomes the de facto timekeeper, right? From which all other DCs in that domain get their time. So careful planning centered around this guy, and specifically the Forest PDC Emulator is the big one. And that's the one at the very top of the food chain there from which everybody gets their time from. And one of the things to consider is making sure that that particular entity has some external stratum time source. That can be either a stratum 1 time source, getting it from the outside world. You guys may already have time servers in your environment already, and you want to point to that. But the idea is to make sure that you configure that PDC emulator to grab time from an external source of some kind. I think that's the key. And we would strongly urge you, VMware strongly urges you to make sure that that PDC emulator is a physical entity. Not necessarily in every single child domain that's a part of that, but at the very least the forest root domain PDC emulator should be strongly considered to be a physical entity, and we'll get to that in just a second as why. The rest of the bullet points are here just showing you the relationship between DCs that are in a domain and all the others and who they get time from and so forth. All right, why is it so important? Why is AD's time synchronization such an important entity? Well, it's based on Kerberos. Kerberos is a very time-intensive or time-sensitive type application. As you can see, in Active Directory, and probably most of you know this, it's got a 5-minute tolerance. If a domain controller becomes more than 5 minutes out of sync with its other domain boys, what happens? Well, some ugly things start to occur. Like all of a sudden, logon requests are refused. Session tickets that were granted to access resources expire. Replication stops. Okay, it can be a really nasty little thing in the environment here, and we've only got a 5-minute tolerance. It's not the only time-sensitive application that's out there in the market, but of course the context of this discussion is around that. And there are activities, as you all probably well know, within Active Directory that require fairly immediate updates. When you lock an account or disable an account or change a password or various items like that, updates need to happen right away. And of course, if you're skewed too much, that becomes a problem in an Active Directory environment. So that's paramount thought as you go through this. Here's the challenge with a virtual machine. The way that VMware's hypervisor works is that it continually monitors the needs of the virtual machines running on that hypervisor. If it sees that a virtual machine is sitting out there and doesn't require any CPU cycles, guess what a virtual machine is not going to get? CPU cycles, right? If you don't need them, you're not going to get them because I need them over here. And at the end of the day, if you flash back to your A+ Hardware 101, how does the Windows OS keep time? It keeps time by synchronizing with an interrupt timer based on the CPU clock cycles of that physical box. And once it's got that clock cycle synchronization mechanism in place, it processes timer ticks on a regular basis. Timer ticks are what keeps the clock going and keeps it synchronized. If you've got a whole bunch of virtual machines running on a hypervisor, and you've got some domain controllers that aren't in the immediate need for CPU cycles, or you've got another VM that's currently munching up every cycle on that physical box, what happens to the virtual machine, if it's not getting cycles, is it's not processing the timer ticks. If it's not processing the timer ticks, what's happening to the time in that virtual machine? Immediately you start seeing drift. And of course, if you start having too much drift, and it gets beyond that 5-minute tolerance window, now of course we're back to the nasty little problems that come in there. So idle cycles in a domain controller can be extremely detrimental to this process as we go through it. I did a test on domain controllers that were sitting on the same hypervisor as another box that I ran an app that just artificially chewed up CPU cycles, in other words, stealing them away from the domain controller, ran the test for 18 hours, and it drifted by 1,700 seconds. In English, that's 28 minutes in an 18-hour time frame. Now, that was an artificial situation, but could easily happen if you have applications out there that are extremely CPU heavy or intensive. And we know that, and I'm sure you've been to sessions already that talked about this, we know there's a number of things that we can do to avoid having those on a server that's running domain controllers. But if in fact they do coexist at some point, after 28 minutes is a lot. After 5, it's a moot point, right, at that point. So one of the things obviously next becomes, how do you prepare for this? So there's the why behind time synchronization as to so important in this configuration, and what potential virtualization issues you can come up with in that AD environment. But the question now becomes, how do I combat that situation? There's a number of things you can do. And again, I'm not going to read these bullets, read these items here. They're really just for you to be able to go back and review in the future. It has a series of registration settings and so forth. But from a high-level perspective here, what this slide is you can create a group policy for domain controllers container. I'm sure you're all familiar with how policies work. There's a DC policy out there. You can modify that DC policy to use WMI filtering to locate the PDC emulator. Now, at the end of the day, that shouldn't necessarily move around too much, right? Change roles, but could. I mean, if there are things that you're doing or things that need to be modified, and should that PDC emulator move to a different entity, because they can be changed around, this particular policy will allow it to be followed and update. And where is it updating it? It's updating it in your DNS records and your Active Directory domain environments. Now, how do we combat time? There's a couple of options that you have at your disposal that you can use to combat the time issues associated with it. Number one is to just use the already implemented Windows time services. AD does this by default. And what we want to do, if we choose to use that as a method of time synchronization, what we want to make sure that we do is we make some slight changes to that modification, because the default behavior is the PDC emulator uses the clock on the physical server by default, and we want to point it to an external stratum server so that we can have guaranteed time synchronization and make absolutely sure we're in the boat here. So through registry changes, and of course after stopping and restarting the services, we then can continue to use that process. We've just configured our domain to actually talk to an external source. And some of you in this room here probably have already done that. Okay? And that's perfectly acceptable solution. The second option is that you can use VMware tools to do this configuration. Again, we go back to the modification settings here, but we're changing it from its NT5DS setting to no sync. What we're doing is we're prepping the domain to not synchronize using that methodology, but we're going to leverage VMware tools to do that for us. The next step, of course, is based on our knowledge base article that you can get from our website here on how to configure the ESX servers to synchronize their time with the Stratum servers in your shop. And again, the logic or the idea here is that we've got every single ESX server pointing to the same time source, and then they are on a periodic basis, synchronizing their time with the Stratum server. And once we've got all of our ESX servers time synchronizing, we then go to VMware Tools and put a tick in this box. Now that tick is not set by default. Okay, reason that's intentional. VMware does not set that because we have no idea what method you're using for time synchronization. When you put a tick in that box, you are telling the guest OS, you're telling VMware Tools, within that guest OS to make sure on a periodic basis it synchronizes that guest OS's time with whatever the ESX server is using as its time mechanism. Okay, does that make sense? So there's a couple ways that you can go at this. The challenge to VMware Tools side of the house is that this tool, if you didn't know this, little back history on it, VMware Tools is always designed to play catch-up with time, not slow down. If a situation should occur in which the guest OS becomes ahead of its time, it will not slow down so that it catches up. It will always be ahead until you manually change that. Okay? What happens when we do the VMware Tools synchronization method is that once we get the time off the ESX server, we process timer ticks. If you use the first method, then if a virtual machine where we are not asking VMware Tools to synchronize its time with the ESX host, then we are allowing Windows Time Service to do that. But again, we go back to the concept of if I'm not getting cycles to that particular box, then that means that's not processing the timer ticks. And as long as it gets to talk to that PDC emulator within a 5-minute window, then it'll process its timer ticks. Now, the most important thing is that this tools method here, this tools method does not jump ahead in time. If, for example, the virtual machine sees, hey, I'm a minute behind, it won't just change its time a minute up and catch up in a minute. What it actually does is it processes all of the queued timer ticks faster than the clock cycle that was set for it. So, if you think in the context of music and a metronome that goes on a regular basis, that's essentially how it happens with a physical server. In the context of VMware Tools, should there be stacked up or queued up timer ticks sitting in that guest OS, and it goes to check in and say, hey, you're behind, it just runs those timer ticks faster. But it has to process them in sequence. And that's important because jumping ahead in time and flipping back and jumping ahead and flipping back causes problems with ADs, update sequence numbers, and all kinds of fun stuff. Does that make sense? Okay, so that's either way of the methods here, that's the key. The end of the day, pick one or the other, but do not use both. If you use both, you'll cause flip-flopping in time. And flip-flopping is not good for Active Directory because it doesn't process timer ticks properly. It doesn't do the update sequence numbers properly. So really, VMware is good with either method that you use. We'll support either method. That's fine. Just pick a method, one or the other. Obviously, your layer 8 decisions, you all know the 7 layers of the OSI model, right? This is layer 8 decision. It's the political layer that we all have to deal with. That last bullet, I mean, your decision may be based on a layer 8 decision. I don't know, corporate policy mandates some wacky things sometimes. But so that's the time synchronization component of this and things to think about as you get into that. Performance from the other side, this is also kind of a misconception. A lot of people will tell me that Active Directory shouldn't be virtualized because it won't perform as well. Well, I guess at the end of the day, when you look at a virtual machine, frankly, if it's sharing resources with other virtual machines, is never going to see 100% of the native power of that single physical entity because it's sharing resources with other VMs. But it'll certainly be, and this is a conservative number, 85 to 90% of it. Well, domain controllers in most data centers never really use more than 10% of its compute power anyway. So it's generally not a really big issue. This is a very small even argument that you can make. Obviously, the advantage of having multiple domain controllers or more domain controllers, since they're software entities, can give a greater logon experience, especially to things like remote offices and so forth, because you've got more options for the logon authentication to take place in there as well. Less points of failure and so forth. A couple of other things. We said that we can add some pretty beefy sized virtual machines now, so there's a great deal of flexibility in there. With the x64 technology, as I'm sure everybody in the room here knows, vSphere 4 is strictly x64 now. We can, of course, trade I/O for memory in that configuration, these 255 gigabyte machines that you can create in there. We've made some really nice enhancements to the networking throughput now, as you can see. All of this stuff you can actually, there's sessions that talk about the new updates of vSphere 4.1 in there as well. IOPS have been greatly, significantly improved as well. So virtualization doesn't increase performance. That's somewhat of a misleading bullet, because if I am in fact running an Active Directory domain controller on my old 486 DX66, and I now am running it on a box that's processing a couple Xeon processors, yeah, we should see some performance increase there, but apples for apples, virtualization does not make VMs run faster. It's still important to make sure that you follow Microsoft's best practices about where to put the FSMA roles. We're not telling you to go against the policies or procedures and the best practices that Microsoft says about FSMA role placement. So you should still factor that in and consider that. Let's talk about replication issues in here. It's important to make sure that you check your replication topology on a periodic basis. I think that probably one of the most unsung utilities that was available in Windows 2003 was Replmon. That actually was amazed at how few actual AD folks that are supporting that never really look at that. This, of course, tells you the connectivity between these and whether or not it's actually happening. The graphic at the bottom here is showing us an error. That means there's a replication problem that's taking place between two virtual machines for whatever reason here. And, of course, as an admin, you now need to investigate that. So you want to make sure that you're looking for replication errors. Repadmin for Windows 2008. This is just a graphic that's showing we have positive inbound connections taking place. That means all my schemas are being updated. Infrastructure stuff along those lines is getting updated on a regular basis. Just a graphic for Repadmin. This is, of course, the tool that's used in here. This is where the other was a graphic tool. This becomes a command line tool. I've highlighted in the boxes here that this is indicating a couple of inbound errors here. So where the other shows us a nice, pretty little picture, this can drop to a command line, which allows me, that can be executed remotely too, which is also helpful. Again, there's still yet more utilities out there that can help you monitor the health of your environment. There's DC Diag and NL Test. Win 2008 R2 has got now an analyzer that's available that we can look at as well. Health scanners that you can download from Microsoft's site as well. So there's a number of ways in which we can validate and make sure and monitor that our replication is occurring. Just a screenshot to show you DC Diag, just some various types of outputs that come in here. It'll tell you a number of different things. So if it's a utility of choice for you, by all means use that as well. It came out with 2003 and 2008. All right, pressing on to probably another one that's kind of high on the list, high availability and disaster recovery. So rule number one, continue to do your system state data backups. Cloning a domain controller is not a proper backup. We have actually I've had clients tell me that, yeah, I take a snapshot of the domain controller periodically and I make a clone of it, since now we can do hot cloning. And they'll make a clone of it and that becomes their backup. Well, I'm sure everybody in the room here is surely familiar with the fact that a clone is not a backup, right? So don't do that. Continue to keep those, and you probably have commercial software that's out there doing your system state data backups. Continue to do that. There's the knowledge base article for FSMA role placement in there as well. Excuse me. You should use Microsoft's methods of restoration. And we're going to get into why that is in the next slide or so. Make absolutely sure that you do your restores exactly how Microsoft puts us through the restoration process. And I've kind of hit home on there. Do not assume that a backup is going to happen from a duplicate copy of a domain controller in there as well. The second to last bullet point, do not use snapshots. In fact, I will expound on this to say that Microsoft has specifically said we will not support any domain controller that has been snapshotted. So don't do that. In fact, there's a couple of ways. For number one, it causes easy corruption, can also start some really significant performance degradation fairly quickly. But more importantly, and probably top on the list, is it's not supported. So you don't want to go down that road if you have to open a ticket and tell them how you're doing this process. There's a number of ways to avoid that. You probably are all familiar with. I mean, through the permissions available in vCenter now, I can actually set permissions to prevent somebody from being able to take a snapshot. You know, there's the persistent disk versus the non-persistent disk option that's also out there. So there's a couple of ways that you can actually stop it in its track and prevent that from taking place. Don't put a virtual machine that's running Active Directory into pause for very long. You'll start to get some issues associated with records that terminate, right? Become time-bombed or tombstoned, as they like to call it. This is kind of a couple of, looking at a graphic here about the disaster scenarios here. Proper versus improper. On the left-hand side, the improper restoration of a virtual machine. This is the guy that takes a virtual machine that's running domain controller and makes a clone of it. And then when that initial VM crashes or becomes corrupt, he pulls out his clone and he fires it back up. So a couple things about this. In the left column there, you see a virtual machine domain controller, how it sees itself. And again, without turning this into a Windows Active Directory class, one of the things that's extremely important about Active Directory is some of you in this room are probably not even old enough to know what NT4 is, but I will tell you that back in the day, that scalable thing called NT4 had two types of domain controllers. Ones that had a read-write database and one that had a read-only. Well, PDC was a read-write database and all backups were read-only. So all backups took their direction from a PDC emulator, right? Well, from a positive side of the house, that becomes a one-stop shop. You're making a change one place and then pushing it out to your backup domain controllers. From a potentially con side to that, you got a single point of failure. So what Microsoft did with Active Directory is turned every domain controller into a read-write database. So any DC could accept a change and then replicate it. Well, that significantly improved things now, because if I happen to be talking to this DC, he'll take my change and pass it around to everybody. They do that through the update sequence number. Every record has a USN associated. You can see this USN number. And every time you make a change to it, increments it. And then on a periodic basis, domain controllers all pick up the bat phone and talk to each other and say, hey, have you got any changes? Yeah, I got some changes. Pulls changes back and forth, and they compare notes. And they find the USN that's got the highest value and place their record with that change, right? That's the simple side of the house in here. Well, if you make a clone of a domain controller, another component associated with that database is the invocation ID, which is, an oversimplification, but it's a rev number for a database, right? That's what it is. And the update sequence number and rev number for that first domain controller over there, you can see the value of 23,000 and invocation ID of A. That means that if I clone it, what's its invocation and USN number going to be if I bring it back on live? It's going to be that old number, right? So now the second domain controller that's in this domain, initially they have the same sheet of music that they have singing there. We have a crash. We pull that clone disk out. When we pull that clone disk out and power it back up, it's still got that old USN number, and it's got that old invocation ID. And lo and behold, the second domain controller in there is looking at that going, that's very different than mine. And the first domain controller makes changes, and they never get back into sync again. Okay? So they're always out of sync, and that's where our problem runs in. Of course, on the left-hand side, as you can surmise from what I just said, that when you do a recovery, proper recovery of a database on a domain controller, it resets the invocation ID so that all the other domain controllers understand, oh, he's got a different database, right? So that I'm not looking at the same database ID. I see that that first domain controller's got 2 invocations or 2 revs, and it will properly copy over the records in there. So that's the most important reason about why cloning and snapshotting is not a good idea to do this for Active Directory. So let's talk about some vSphere functionality that we can leverage in our environment here. You probably all know that HA, the high availability component, is a mechanism for the recovery of virtual machines that were running on a server that's catastrophically failed. The whole concept here is, although it's not zero downtime, that we will restart virtual machines on the remaining hosts in the event that there's a catastrophic event and the host unexpectedly goes away. Well, we can set, and might strongly consider doing this, set the priority of the restarting of those virtual machines differently for domain controllers and others. And this, of course, is used by HA in the event that there is a catastrophic failure to prioritize which ones I need to bring back first. Now, there's an interesting little caveat with this, and I don't know how much exposure you all have with HA, but if there is enough remaining horsepower in the ESX servers that are still in that cluster to start all VMs that were on that host, right? You may or may not know this. So if I have 10 virtual machines running on a host that catastrophically failed, and there is enough remaining resources in the remainder of the ESX servers within that cluster to start those 10 virtual machines, restart priority is insignificant. Because HA is going to say, well, hey, there's enough gas in the tank to start all 10 of these, and it'll just power up all 10 of them. Well, there goes your restart priority out of the window there, right? Of course, so that's something to consider here. However, on the flip side of that, if you've only got 3 boxes in there and one fails, and you need to prioritize which ones come back, well, you may strongly consider, instead of bringing all the DCs back up, I might just bring one of them back up. Okay, and you can, of course, limit your exposure in here. It works. Just understand the implications of doing this. Has anybody in the room here ever had the joy of trying to start up an Exchange server that couldn't find a domain controller? Exchange loses its mind if it can't find a domain controller, right? So you got to be careful a little bit with how this works, because if there's enough gas in the tank to start everything, that Exchange box might come up before that DC. So there's a wonderful little feature built within vCenter that has the capabilities to do this and leverage this, and that's the vApp. Now, the vApp has been largely designed as a mechanism for tiered applications, applications that have very specific dependencies on each other. And a vApp is nothing more than a container within the vCenter inventory to which I add virtual machines and can manage those VMs via permissions and resources and so on and so forth. And as I drop a bunch of virtual machines into this vApp, I can actually start the entire vApp or shut down the entire vApp. But one of the other wonderful features built within that is the restart order. So if I have a scenario in which I want to make absolutely sure the DC comes up before the Exchange server comes up, we could drop one of each of those into a vApp, set the restart order in there, and then when that vApp fires back up again, it'll make sure that they come up in the proper sequence and come up in the proper order in there. So it's something to consider as a mechanism of leveraging the utilities and the features that you have in your environment in there. And it's kind of one of those little unsung, hidden little nuggets that we have in our environment that can be used beyond the concept of what it really was intended for, and that's tiered applications. So another consideration. Also, we have clients that say, from an isolation response, what happens if a host becomes isolated? Didn't fail, but it can't talk to anybody. Make absolutely sure that your DCs are leave powered on. Again, that's something that probably you've got as a practice already, but I'll just reiterate that as well. Leveraging DRS's features, anti-affinity rules. Imagine a scenario in which that host that just failed just so happen to be running your entire AD infrastructure. Okay? Well, an anti-affinity rule is a rule that says do not allow these DCs to reside on the same host. And what you're doing is effectively spreading the wealth throughout your cluster so that the greater likelihood of multiple servers failing versus a single server failing greatly, obviously, increases your odds of having a DC up and running in there. So anti-affinity rules, by the way, in the latest release have now gone beyond just the two. If you didn't know that, that was a limitation that we had a long time. Although it would allow you to add multiple servers in a DRS Anti-affinity rule, more than two or three, it only recognized the first two listed and ignored everything after that. So you couldn't create an anti-affinity rule with 3 servers. You had to create 3 different anti-affinity rules between the pairs of servers. Does that make sense? I guess back in the day, the programmatic logic to do that was more than they wanted to deal with at the time, but they've now figured out how to programmatically do 3, 4 servers in there and keep them separated from each other so that you don't have these multi-anti-affinity rules in there. So certainly another big enhancement that's coming down the pike there. So does this make sense? I mean, this is obviously something, and again, these are just not overly complicated things that you do as an administrator, but they certainly greatly affect the outcome if something should happen. Okay, so in summary, we're saying leverage some vSphere functionality in here. We're also saying make sure that you've got a proper recovery solution in here and do not use cloning or snapshotting. What we're getting at here is that you absolutely want to continue to do it as well. Tombstone issues are obviously something you want to think about in here as well. So one of the other items is that the VMware fault tolerance is potentially another option available to you, especially for PDC emulators. That might be something else to be thinking about in there if you've got the gear to do that. That's kind of that's going to be the big sticky wicket for that one. Okay, so we're good with the challenges. Let's take a look at how do we get from here to there. So what we want to look at is what's part of the steps in thinking about the successful migration of this entire strategy that we're talking about here. First things first. You know the old school, your mom told you never do anything unless you back it up first, right? Before you start the journey, make sure you've given yourself a way to get back, okay? A number of things could derail the process. Consider using dedicated internal switch or virtual machine port group in here. This is largely for isolation of replication traffic. This is initially standing up my domain controller as a VM and allowing it to replicate or giving it its own pipe so that it can replicate. That's something so you can isolate some of your replication traffic. It's not a requirement, but it's something that you might want to do, especially if you're a big shop or a big organization and you've got a big AD database out there as well. I always tell clients, start with single processor virtual machines. Don't build a virtual machine with 4 processors because the physical box it ran on had 4 processors, okay? Start small. You can always add, right? You can always add more of these, and depending on the OS that you're running this on, you can actually even hot add processors if you had to. You can do that if you want. But generally, that should be more than adequate for most domain controllers that are sitting out there. Make sure your connections are working, Replmon or Repadmin. Give it time. AD will do an initial replication, but for those that are not super AD heavy, there's a lot of behind the scenes going on for it could be up to 24 or 48 hours. Might be a good thing to do Friday before you go away, let it replicate over the weekend, and pick up where you left off on Friday, Monday morning in there. Now this next bullet, which I've got a series of slides on, is a mechanism that you can use to kind of shift or prioritize or redirect where you want the logon authentications to go. So if your idea is to move completely from a physical world into a virtual world to do this process, at some point you want to wean all the logon authentications off the physical boxes and start pointing them to the virtual machines, right? You can do that through DNS. DNS can be your friend in this regard and redirect logon requests. There's a number of things you can do, but this is one way that we can do that by changing the weight and priority of DNS server records in there as well. Monitor logon requests, make sure that they're going to where they're supposed to go and that they're responding. And then, of course, if your goal at the end was to decommission Your physical servers, you can take them out of play at that. One item that I do not have on this slide here that I will make absolutely sure that VMware is solid on for you, do not P2V a domain controller. Technically, you can do it. And it does have some hit rate, but it isn't 100%. The P2V conversion process, remember, and I can't drive this home, all the way back to P2V Assistant, the first utility that we had. P2V Assistance and Converter's job is largely for one function, and that is to convert an OS that boots on a hard drive to one that boots in a virtual disk. There is nothing gained, zero, nothing gained from converting data. What we're doing is we're modifying a physical box's bootstrapping to bootstrap in a virtual machine. You're not doing anything with the data, and unfortunately in the conversion process of a domain controller, it oftentimes, in the way that it does it, corrupts the data in the database. And in many cases, I've run across, it won't power up. How hard is it to stand up another domain controller, guys? DC promo, another domain controller in the same domain. Call it a day. Right? That's it. I mean, really, let's be perfectly frank about this. It's not a super complex process. And it's so much better to do that than try to wrestle with the conversion process. Hit rate I would get, I've never actually monitored this, but I'll tell you, to be frank, the hit rate on a P2V of a domain controller is probably about, I'm going to guess, 30 to 40%. It's fairly low. I've done it in my house, on my lab at home, and it works sometimes, and other times I just can't get it to come up. And it's not even worth the time. By the time I figured out how to do it, I could have built 10 domain controllers and started. So don't waste your time with that process. DNS modifications, transitioning piece of this. So here's where we're trying to redirect the logon requests from what was going to all these physical machines to the virtual machines now. And we can do that by modifying the SRV records within DNS for specific entities, obviously. And what we're trying to do here is get them away from the old boxes onto the new. And also, more specifically, trying to avoid the PDC emulator from receiving as many potential logon requests. Okay? Now, the reason for that is because the PDC emulator, as I said, not only the gatekeeper, he's a busy little beaver doing other things that are out there. So if you've got enough DCs in your world, this is a box that you might want to kind of limit the number of logon requests that it go to. What we're doing, we have two parameters that we can dance with here, DNS weight and DNS priority. And DNS weight is the proportional distribution of those requests. Okay? As you can see, I've got a couple of settings down here at the bottom. The first one is showing the LDAP server weight, which we're suggesting that you lower to about 25 or 50. Its default value is 100. That means that for whatever DNS record for this domain controller, 100 represents 100%. And that means that that box, there's a 100% chance you may receive a logon request of the proportional distribution of requests that I receive. Right? Does that make sense, everybody? That there's a 100% likelihood you may get that. If I drop that down to 25, what I've said is for that domain controller, proportionately, everybody else should get 75, and this one should get 25. Does that make sense? So you're actually telling DNS how to distribute these logon authentication requests. The next one, of course, is the priority, the LDAP server priority in here, which has a default value of 0. If you push that to an artificially high number, like 100 or 200, you've significantly decreased, the likelihood that that server will ever receive a logon authentication request. So it's the flip side, where the first value defaults to 100%. The second one defaults to 0, which means, everybody's equal. You're all created equal. That means that any one of you could equally receive the request. And if I change that to an artificially high number, then what I've said to the DNS server is that I want you to significantly decrease the likelihood that that logon authentication request will go to that particular box. Now, you do this certainly for the PDC emulator, but you also start doing this as you want to wean everybody off the physical boxes and redirect them over to the virtual machines, right? It's a way to stop sending logon requests to the physical servers so you can ultimately decommission. You can do this through the DNS manager. It's fairly easy. You just simply go in there and change the weight and priority for whatever domain controllers you're trying to do this with. Does that make sense? And away you go. And this is immediate. You don't have to start DNS. I would suggest you flush the cache, but you don't even really have to do that because DNS is going to pick up on this anyway, but it's an immediate change once you put it in there. Or you can actually, as you can see down here, there's a DNS record showing the change in there as well. So a couple of things to go about. You could do it through registry settings too if you didn't want to do it through the GUI. But so a couple of other additional machine considerations, virtual machine considerations as we go through this configuration. Obviously, adding, modifying, searching, update operates can benefit significantly for memory caching. What we're getting at here is that we're trying for domain controllers, consider sizing the VM in a way that will allow the Active Directory database to reside in RAM. If there's not enough available to put the database into RAM, then it will have to do disk searches. And of course, disk searches, doesn't matter if it's physical or virtual, is going to slow things down a little bit. Okay? Microsoft's still got that AD Sizer out there. If any of you have never seen that, has anybody ever looked at that tool before? AD Sizer will actually allow you to see how big a database is going to be. You put in the number of users, number of groups that you have, and it's a calculating estimator that will actually tell you what the size of the database is going to be. And you can use that value to help you determine how much RAM you're going to apply to a virtual machine. Again, same thing I said here before with regards to segregating the disks out. Microsoft still says that there should be a separate, whether it's physical or virtual, there should be a separate boot disk, separate database disk, and a separate log disk for transaction logs. I kind of thrown together here, really from a high-level perspective, looking at some of the sizing elements that you should consider in this. Obviously, the platform is up at the top here. We're assuming this on a vSphere 4 environment. Processor, generally one CPU for smaller shops, and 2 or more for bigger shops that are out there. From a memory allocation side of the house here, you can see that if you have, and I just tried to use some examples here, if you got 100,000 objects in Active Directory, that'll produce about a 2.75 gigabyte database. So you do the math. If I need to get that in memory, then we're talking about like a 4 gig allocation because I've got to have enough for the OS to run, right, and so forth. 3 million users, 3 million objects in the database, which sounds like an astronomically high number, but if any of you are familiar with some of the really big companies out there, by the time you start talking groups and you start talking users and all that, 3 million is not that insignificant a number when you get in there because lots of stuff in there. So we're trying to give you some numbers around that. Use the enhanced networking functionalities that's out there, perhaps putting it on a switch that has teaming in case you lose a link. Again, there's sessions out there that talk about this as well. And down at the bottom here, we're identifying separate virtual disks, even on different SCSI controllers. Again, we can do that by simply building a virtual machine and allocating the size along the way. Of course, a couple of things on lead practices here. We want to synchronize the Forest PDC emulator to an external source. Snapshots, bad. Again, I need to add the record in this slide deck as well. No P2Vs or converters. Don't do that as well. Keep monitoring it. Make sure you don't suspend for a long time. Regular backups, of course, is very important in there. And then, of course, there's a couple of other functionalities that we've got in here as well. This is our environment. This is what Active Directory looks like at VMware. We have about 9,000 users. That's excluding the groups and stuff. We have 33 sites. We have 48 domain controllers, 1 physical. Guess which one's physical? 4 is PDC Emulator. Okay? We synchronize that to a Stratum 1 server, and the other 47 domain controllers have been running uninterrupted for the last 5+ years, virtualized. Okay? So we speak what we eat. And it actually has done very well. Most companies will do that in their, get very good results in there. Can I run an environment that's hybrid? Of course, absolutely. Could I technically run an environment that's fully virtualized? You could, but I think we've already gone down the path there of some of the things that you might run into. So, okay. There's some additional resources. Just wanted to give you the links to some other items that are sitting out there. There's actually a white paper on this that I wrote for Active Directory, so you can go out and download that from the side here as well. Just some additional VMware website stuff for the various types of applications. So thank you all very much, and I'll just step off.